basically what we would generally want is we would want to make decisions based on certain conditions. If this happens, then please do this. Otherwise, do this. This is a general thing that we come across in our lives also. If it rains today, please carry an umbrella if the rainy season on, or anything at all. If your salary falls in some bracket, you need income tax to be calculated in some percentage. You want the grades based on some percentage of marks. So ideally, decision making is what we come across constantly. This is like generally happening, generally required by us. So for that, what support do we have from the language? So we're discussing the language now. What is the language? Language offering us. Now this language part that we have in C++ is the same as we had in C language. So those who are familiar with C language would find this easier. The same thing, because it's the same thing, it's easier for them. But nevertheless, any C++ course would cover this from ground up. So that is what we are doing here. We are covering this one by one. So we have this if else is one statement that the language offers us. Then we have if else if. We have the switch statements. We have switch expressions. We have case constructs as they are called. And within case you have the default construct. So we will examine them one by one. Alright, so here as part of this, what we have is we have variables. So as part of the uh, agenda, the objectives for the session, we are covering variables, local and global, statements, flow of control, selection and iteration. So that if else and case construct was coming in the category of flow of control or selection, and we have iteration, that is looping. So that is another set of statements again the language is offering us. Let us see them one by one. So here's a small program where we have the main function. So main function is basically the main entry point of a program. In C++, what happens is, see, C++ is a compiled language. Whatever you write is basic English statements like int main. You have the opening brace. Opening brace is to indicate that whatever is following after this, the various statements, they belong to this uh, block, belong to this part. This is one part, the main, until you find this closing end of block. This is end of block, and this is the beginning of the block. And you have this statements with two forward slashes indicating that these are comments. So whatever you would want to write as something which is for reference, for reference of reader, you can write that with two forward slashes. That is something which will be ignored by the computer, by your machine. Okay, so now coming to the program, how does the program execute? So you write your program in English-like statements. These are the C++ language statements, main, and this and that, whatever you see till the end of the block. What happens is you write the program, you save it with a .cpp extension. So let's say if the file name is main, you will name it as main.cpp. Alright. So you will be naming it as main.cpp, and what will happen is um, your program, there's somebody called as part of the computer, there's somebody called as a compiler, interpreter. So this interpreter's job is to convert your your language code into the machine language, which your computer will understand and finally execute for you. So there's somebody called as a compiler. What he does is he takes chunks of code as a block, compiles it and converts into the corresponding exe or object form, which is executed by the machine. That is how it happens. And if there are any errors while compiling the program, the compiler will tell you. So let's say after every statement, the statement has to be terminated with a semicolon. That is how the language has been written. And if you forget the semicolon, the compiler will give you an error, and it will not proceed further unless you put the semicolon back. So it is as good as saying that, boss, your program is not understandable to me. What do you expect from the machine? So ideally you have to change it because it's not in the language that we understand. And he is a person who strictly follows the semantics. Since he is a dumb, I mean he's a machine, dumb, totally dumb, it has to be given everything in the format that has been specified. So the format says every statement needs to be terminated with a semicolon. And if you are indicating a block, if you have to say that these blocks, this set of statements belong to something, you have to indicate it with an opening and a closing brace. So this is called a brace here, opening brace and a closing brace. And these two forward slashes indicate that it's a comment. Comment is basically for a reader and not for the machine. So within a comment, anything in any form can be written. All right. So and again, the program is shown here that you can even nest blocks between one another. So if you see that if you want to do some conditional execution, based on the condition the execution has to happen, you can put an if block within the main. Main has to be there in any C++ program. Main is the entry point and the exit point of a program. So for a compiler, if he is going to compile your program, take your program into consideration in first place, you have to have a main. Okay. And why this int, we can discuss this later. As of now, we'll just leave it as it is. You'll just follow whatever is given to you, but we'll understand why this int maybe a little later. And this hash include statement is basically telling your program that whatever statements that we use here, you can refer to these statements, you can find a reference about these statements, how they are working. Like cout we are using here, we're using cin. So cout and cin, what they actually do are defined in the IOStream header file. So this is a library file. This file is provided to us by the C++ language. Basically, the creators of the language have put in all the functionality related to cout, cin. So cout is basically for output, cout, and cin is for input. So anything relating to input and output, the functionality is being given in this IOStream file. IO is input, output. So this is basically a library file, a header file, which has to be included for the compiler to come to know that how these statements behave. All right. So if you're using cout and cin in your program, this library has to be included. Otherwise, my compiler will not really understand what these statements are. All right. So that is hash include. So apart from IOStream, you would have many more header files and library files which would be there. Depending upon the functionality that I'm using, I'll be including them in my program. Main is going to be the entry point of your program, and using namespace is not really required unless you're using, you can use something called as an std namespace for standard library functions. But again, we can skip this as of now. We'll just look at it a little later. So in this program, we are asking for a number, cout. This program will display a message on the screen, enter a number, and int n value is declaring that variable n value. So a variable n value is being declared. Whatever number the user enters will be taken in n value. So we are just allocating some space in memory, saying that n value is going to be an integer variable, numeric variable, and with a cin statement, you're taking that n value as an input. So the program displays enter a number on the screen. Now, since it is normal English, the person sees it, he says, oh, enter a number, that means I have to enter a number. And whatever he is now going to enter after this, that will be coming to you as an input in the variable n value. And after this, we are checking is n value greater than 0. So this is the operator, relational operator greater than, your variable n value just declared, and the if construct. So this is how you put the condition. You put the condition in parentheses, as they are called. These brackets, round brackets, are called parentheses. So if n value greater than 0, again a set of statements belonging to if. So you have a beginning of a block, okay, and which is where you will put in the statements. Cout. So you're telling him whether it is a positive number. So you are saying cout n value. N value will show you the number. So suppose if I've entered something as 7, and 7 is definitely greater than 0, so I'll get the output cout 7. N value will be replaced with the actual value of the variable. stored in the variable n value, and is a positive number since it is in double quotes, will be displayed as it is. And endl is basically for a new line. So after this, the second statement will come on a new line. Okay, so if you see these two less than signs are basically for appending as many streams as you want. So you can say this n value is one variable. Onto this variable, we are adding this is a positive number as another string, and then a new line. So this will come as one single statement. Another cout, so another display, another line in display will be double this number is, so this will display the n value. Star is for multiplication into 2. Basically, let's say if the number was 5, this would mean 10. The output will be double this number is 10. Again, NL, that means on a new line. If anything would have followed, but since there's nothing, NL is making no difference here. And then a closing of a block, which indicates that if block is ending here. So here in this example, they are saying that if the number is entered by the user as 3, then this is what will be displayed. Alright, so this is another program. Enter a number. If the number is less than 10, it will display so and so. So again, we are saying that there is no practical limit as to how many nested blocks we can have. We can have an if within an if and within an if as long as possible. So you can see there's an if. Within that, there's one more if. Alright. However, it is generally a good idea to try to keep the number of nested blocks to at most 3 or 3 blocks deep only, because for understanding purposes and also for the compiler, because the deeper the nesting, the more work for the compiler and the slower the program. And if you are needing more blocks, then it's better to create multiple smaller functions. What are these functions? We'll look at definitely in the next session. And then these variables are basically, as I was telling you in the beginning and now also, that they are there to store data for us. Okay, and this data is of various types, which we looked at in the session, variables and operators. So this data can be character, can be integer, can be float, can be anything. And these variables can be of different types. Again, this can be local or global. Local means it's something created within that same block. So if you see, a variable scope determines who can see the variable and how long it lives for. Okay, so how do we know when will the variable die? So in the memory, the variable will be there as long as it is there in that block and that block is executing. So let's say if we talk about this variable n value here, it will be there as long, it will be live as long as the if condition is executing. The moment the if is condition finishes execution, this variable dies out. Had it been created here, if n value int n value here, but since it has been created here outside into an n value, it will be available to this if and to the outer if and also to main, since it is a part of main, the block in main. So the scope of this n value is in the main block where it has been created. And it will die out the moment you encounter the closing block, the closing brace of this function main where the variable has been declared. So this is called declaration, variable declaration, int n value. This has been explained here in detail. Okay, so variables just declared inside a block are called local variables, and local variables have block scope. Okay, so within that block only. And variables with block scope can be accessed only within the block they are declared in and are destroyed as soon as the block ends. So here's an example for you. So they both are destroyed when main finishes execution. And variables declared inside a block can only be seen within that block. Because each function has its own block, variables in one function cannot be seen from another function. So example can be main. If the function variable has been declared in main, it is not available outside main. So there are furthermore examples which are there. We can go through these examples to get the idea clearly. So actually speaking, you can get this very clearly when you type out the program yourself and you see the results. So it makes really makes sense then. So as of now, I'm just try running the program, going through the program. You have this main function where you have this variable n value, and so n value is declared in main. So you can have this one more thing that you can notice is the blocks can be created anywhere, even without the if construct. So the blocks can just be created to maybe to nest to create another level. So double d value is equal to 4.0. It is just put in a block. So if you see this d value is only available to this block, the moment this block finishes execution, outside d value is destroyed. So that is basically what we're trying to say here. Similarly, you can go through this example below to understand it in a clear uh, pattern. Okay. Then there is something called as global variables. Now, variables declared outside of a block are called global. As simple as that. Whatever was declared inside the block is local. Now, what if you want a variable to be available to an entire program, maybe to all the functions, maybe? You can create the variables of global scope, okay? And these variables have been created at a program level. So we will see how. So here with examples, you have this main function. See, this is how. You have created this variable even before main. That is possible. You can declare the variable int. See, this is just a name g and x. You could just give any name. Now, the reason why a g as a prefix has been added is to indicate that this is a global variable. So, this is the name that is given to the variable as g underscore nx. This could have been just nx. This could have been a numeric x. This could have been a x. So the name can be anything, but as far as possible, we give meaningful names to our variables. So G here is to indicate, so wherever you encounter this variable now in the program, looking at the name itself, you will come to know that this is a global variable because of this meaningful name that we have given here. Alright, so you have this main function. So you have this gnx declared above main, and in main you have this variable ny, and you have a single variable ny. And now see, within main, if somebody changes the program, gnx is equal to 5. Okay, so gnx gets the value 5, and if you see outside this block, ny is not there, ny just dies out, but gnx would still be there. And uh, if anybody just makes, see now here again, uh, this is another example of the similar fashion. Variable declared outside main as gn value, okay, and extern would even make it to be available to other programs, okay, other programs, right? Yeah. It is for exporting the variable basically. If you say this in main, we can just change the value of gn value to 7, and any other program can actually change the value or even access the value cout. So anywhere else, apart from main, if you just in some for in some any other block, if you just say cout gn value, you will get the changed value of gn value. So this is another example. This is basically used when you have to make use of the variable in multiple files. So the same variable, let's say you are using, you want to keep alive of the number of active users on your website. So now if you see, there are so many user sessions going on, and we want to keep this value alive for all the sessions. So a global variable will be required here, which will be maintaining the number of the count of active users. So basically what you can do is you can create a global variable in a file, and that file will be referenced in every other file wherever this count is required to be updated or to be displayed. Right? So this is what is being done here. This is a slightly at an advanced level. Maybe you can try it yourself and see. So basically what we are doing here is we are creating a global file as a global.h, and we are including this global.h in every other file wherever this variable will be required. Gn value variable will be required. And just to make sure that this global file, since let's say if you have 5 files, you can have, in a project will be definitely having multiple files. It's not just single file which is doing all the functionality. We have to segregate the functionality into smaller units. So we have separate .cpp files. And you would like to include this global.h file in every .cpp file because you want to maybe modify the value or display the value. So this is how you include it. You say hash include global.h, but chances are that the previous file has already included it. The compiler will not allow two copies of the same file. So in that case, we use this hash if endef statement. Alright. So maybe you can explore this further, but as of now, just a mention of this to have you a clear idea of things. Alright. So generally speaking, if a global variable is going to be used in more than two files, it's better to use the header file approach. So create, what is header file? Simple. The way you create a .cpp file in a similar fashion, you just create a plain new text file, okay, and in that you just say int g and value, just save it as a .h file. So you can name it as global.h, simple, and your .h file has been created. So when we want a particular file to be available to multiple files across, you can create a single header file and give it an extension .h, and then you can include it in all those multiple files of yours. And what happens if your local variable has the same name as global variable? So that was the reason why that variable was given a G prefix. Because chances are when you're writing big programs, you use many variables in your file and you run out of your variable names. Believe me, this is a very common thing. Let's say if I'm talking about name or student name, customer name, employee name, and chances are that if I don't give meaningful names, I am just overwriting the previous data with the new data. So if it happens that a global variable with a particular name is already there, and you happen to use the same name for a local variable within the local scope of the file, what happens is the local variables, they hide the global variable inside that block. So in that particular block where the local variable has been defined with the same name again, in that particular block the local will be overwrite the global. Okay, so it will overwrite the global variable. So example is there in front of you. You have an n value variable which is set to 5, and then so this is a global variable and this is a local variable which is defined in main as 7. When I say n value plus plus and I say n value minus minus, when I say n value plus plus, what happens is n value becomes 7 or 8 or 6, 8 or 6. It will increment the local n value, okay, so it will become 8. And when I do this 2 colons, this is the scope resolution operator, 2 colons here. Scope resolution is to indicate that, I am planning to use the n value of the global nature, outside one, the one which is declared globally. So whenever you are in confusion or you feel that this variable exists somewhere in the global scope also, you can make use of 2 colons there. So when you say with 2 colons, then it means a global variable. So this will actually make the n value to 4. Alright. And when I say and when I come here, local n value is destroyed. So unless specifically mentioned with 2 colons, it will always pick up the local variable in the current scope, block scope. So this will cause you trouble. So it's always better to use prefixes for global variables. And as far as possible, ideally you should avoid global variables because they increase your program's complexity. Here's an example. Say you were examining a program and you wanted to know what a variable named gn value was used for. Because gn value is a global and globals can be used anywhere in the entire program, you would have to examine every single line of every single file. So if there are hundreds of lines of code, you will take a lot of time. So it is actually advisable to find alternatives to global variables. Second, global variables are dangerous because their values can be changed by any function. You don't know what the variable ends up getting as the value because there could be multiple programs which could be just changing the value of the variable in any fashion. So it is a dangerous thing. So you will see modern languages have gotten over with global variables and they have come up with many solutions. There are not many solutions available in C++ though. So as of now, probably you'll have to be uh, very cautious about using them. So there's an example. There will be plenty of examples. You can just go through them to understand them nicely. Thanks a lot for the session. Uh, we'll see you next time then.